This media is brought to you by Polyscope.
In the realm of tomorrow, where techniques mind, we ponder, we dream.
Thank you so much for coming on the show. It's great to finally meet you because this is how we meet each other nowadays over Zoom. So why don't you tell us a little bit about yourself and your organization and what you're passionate about?
Well, good to be here, Chris. Thanks so much for having me. So I'm my name is Konstantinos Kallitsis, and
What a
I've
good
been
Greek name. Nice, strong Greek name.
yeah, right. And the Greek name. Uh, so, so I've been pretty much a researcher throughout my life. I my initial background was in natural sciences, and then I moved on to work on a field called bioelectronics, which
Mm,
is practically um, a merge of an interface. Is a field that builds an interface between biological systems and conventional electronics as we know them.
mhm.
And that's the field that I've been actively doing research over the past 5 years on building interfaces between various biological systems and electronics. And then the other thing I'm deeply passionate about is various flavors of blockchain technologies where we can have um, uh, in particular in the connection between blockchain and artificial intelligence,
Mm.
and where we can and different systems that can democratize access to powerful artificial intelligence systems. And those are, I
Interesting.
would say, the two main fields of interest for
So can
myself.
you explain a little bit, like if somebody who's a layperson doesn't understand the bio
Yeah.
interfaces, can you explain and then maybe provide an example of how somebody might use something like that?
Yes, absolutely. So one way to think about it is when you try to combine a biological system and an electronic system, there's various mismatches between those two. One example is what's called a mechanical property mismatch, right? So our skin, our tissue tends to be soft, and electronics tend to be rigid, right? And
Mm.
that creates a mismatch in the interface. Another mismatch is a language mismatch, right? Because our body communicates in ion fluxes, our cell phones communicate in electron currents,
Mm.
right? So you need devices that can translate between the two, one thing, but also can bridge all those various mismatches. And I only mentioned a couple of them. And then for actual applications, like there's different segments of applications. There's, for example, you have implantables as one broad category of applications, which I mean the ready in market example is pacemakers, but like
Mm.
now we have brain implants, which is a much more futuristic, much more high tech application than pacemakers. Then you have wearables, like think of Apple Watch, but it goes way beyond that. And then there's a third sector, which is what's called in vitro systems, which is in practice growing tissue in a petri dish and
Mm.
then integrating it with electronics to, for example, to screen drugs and do all those types of applications.
Wow. So that's stuff that's happening today. That's not in the future. That's happening now.
That's not 2035, no.
So, for example, even though my Apple Watch just sort of sits on my skin, you would consider that as a bioelectric device?
Yes, bioelectronic, yes.
Okay,
So it is
bioelectronic.
on the second category, which is wearable.
Mm,
So all devices that interface with the skin, or they can even interface with our skull, right? So you
mm.
have electrodes that are kind of helmets that you can wear, where you can have some, you know, read some very rudimentary brain signals. But like, I mean, maybe it's a deep loophole that we can go there, but
I
But
love those kind of rabbit holes. I mean, is it something like not like Neuralink, or is it just like a helmet you can just wear on your head?
so there's from what you mentioned all the way to Neuralink, right?
Mm,
The more intrusive and invasive you go, the better the signal you derive. But
right.
obviously, people don't like to casually have their skulls drilled. So, like
Not
the
casually. I don't like
no,
what
right?
just it's not casually. Maybe
No,
seriously,
right?
but casually no.
Yeah. So, like, people that have, I don't know, like uh, drug-resistant depression, like pretty like terminal cancers or like not curable cancers, or like there's a whole spectrum of pathology where actually like using implants is like the reasonable thing to do.
Hmm.
But for most people would not even consider something like an implant, at least now, right? So there's all those lower tier applications where you can use some very basic controls, like
Right.
as in you can read some very basic signals, but like the resolution is extremely lower,
Yeah.
much lower.
But isn't that so is that for things that are not implantable? So for example, my Apple Watch is not implantable, so the resolution is low. But if I had something like a CGM, which actually goes
Yeah,
subcutaneously, would that
that's
mean have better
that's a
resolution?
very yes, that's a very interesting. So, some funny thing, Apple itself has filed uh, multiple patents for CGMs that are integrated into Apple Watch,
Mm,
and they've done it many years ago, but they haven't managed to. They haven't like I haven't seen it. Like I've been waiting for it for the past, I don't know, four generations of Apple Watch, and I
yeah,
haven't
exactly.
seen like I don't know where the again like those things are not published in journals. Like you just see the patent application, which obviously only mentions the things that they have to disclose to
Right.
secure the patent. So I have no more insight to this than any other person. But there's you can have even something like glucose monitoring. You can do it through a wearable, but would be a much lower resolution. And apparently, maybe they cannot get it FDA cleared. I don't know,
Yeah. Or
right?
it's
But
not good, not a good enough resolution to actually make a difference to make
most
it
most
effective.
like most likely that's the thing, right? And then like just doing when you go in the implant version, it's not even an implant, right? It's just a wearable with a prick. Like
Yeah.
then you have extremely good resolution, right?
Oh
You
yeah,
have
of course.
it's extremely easy, right?
So here's a question I have is that so you're working about bioelectronics. It's actually
Hmm.
translating biological signals to electronic signals and vice versa, right? That's basically the
Hmm.
science. So I,
Hmm.
I guess the question that I have is that even with the implantables, even with something like Neuralink, are we at the point today where I can think something and it's able to resolve it electronically outside my brain?
So you can like what I know for sure, and I don't know exactly what Neuralink can do, right? But because again, they only present so much. But what I know
Sure.
for sure is that you can understand which. So for example, if somebody is scared, or
Mm.
if like one for one, you can definitely read like maybe they would be able to detect at this point which words you're thinking of or something like that, but
Oh, so it
you
can
could
get to the
definitely
point
think
where
if
it can actually detect. So if I'm thinking a
it
phrase or a statement in
no
my
no no
head,
no no, but if you're thinking of so if you think something that causes you fear or
mm,
something like that, that'd be very easy, right? Because it's
mm.
distinct areas in the brain that get activated through different emotions.
Well,
Or
plus
like
there's
if you
external
think of
signals
raising
too, right? There's external signals like
yeah.
heart rates, and things like
Yeah,
that.
yeah,
Sorry.
yeah, but also like there's, for example, if it's fear related, your amygdala would be activated, or if it's you're thinking of creating movement, which is also a very interesting thing for implants because you need to control prosthetics. Like
Mm,
one of the key applications is controlling prosthetics for amputees, right?
right.
There you can your your motor cortex get certain areas of your motor cortex get activated, and even if you don't have a hand, like like you you can understand that you want to raise your arm or something like that, right?
So if you imagine your arm being raised or your hand opening,
Yes.
then your prosthetic hand can
Yeah.
open and close.
Yeah.
So
Yeah.
we're at the point today where we can do that. That's
We,
possible.
we are at the point today that yes, like again, not perfect movements, but we're at the point today where this starts becoming possible. Yes,
Oh,
and there's
fantastic. I love that.
multiple teams working on that.
Would you need that implant level thing to be able to move prosthetics and stuff like that, or is it just like you can do it with the helmet?
There's other applications as well. Like
Hmm.
there's it's a whole field. Like the people do like I mean they have sense some it really varies, right? So there's people that have sensors. Say if it's an arm, they would have sensors on the upper non-amputated area of the arm, and then they would detect like as in there's some slight move, like when you want to
So
do
you're
some
tensing you're
movement with your
tensing your
arm.
upper arm, the
Yeah,
signal
and
to the rest of your arm to do
yeah,
this, right?
you were meaning to transmit this signal downstream. That's another technology I've seen where that's the like there's many different ways signals can be detected.
Oh,
But yeah, like
fantastic.
that's becoming with that's well within the realm of possible right now.
So you're able to sense sort of out from the biological to the electronic, and you also go the other way as well.
Sorry, I think the connection cracked. Can you say that
So
again?
you're able to sense. So if I'm creating a biological signal through this, or through my brain, or through muscles, I can send a
Hmm.
signal out to these electronic devices, and the electronic devices
Yes.
can do something.
Yeah,
Does the
they
opposite also happen? Like the electronic device can send a signal to
yeah,
the biological?
100%. 100%, yeah. So like one such application is what's called deep brain stimulation. Again, that's for like one of the main reasons people do that is for drug-resistant depression,
Mm-hmm.
and some other indications, where you I mean, and there's uh, where you essentially send and like you implant an electrode to someone's brain, and you send an electrical signal in the brain, and it interacts with the tissue, right? And
Wow.
it changes stuff in someone's brain, it rewires someone's brain.
Wow. Are you able to get it to actually transmit images and sounds and other sensory things as well? Or is it just targeting those specific areas?
What do you mean by transmitting images?
Well,
Like
let's say
implanting a memory? Is are you referring to implanting a memory or something like
implanting
that?
implanting images, implanting sounds,
I
implanting
don't. I haven't.
sensual sense data.
I've never seen something like that.
Okay, because I'm
Like,
just thinking about
but
sort of bypassing, because I was thinking about like augmented reality, virtual reality. We have to wear these clunky headsets and earphones to be able to feed into our senses. But if we could
uh-huh.
bypass our senses and go straight into our brain, then it would be a much more
Oh,
effective experience.
yeah, yeah. I mean, and I think that's part of that's the like part of the vision behind Neuralink, right?
Right.
It's like the like essentially increasing the bandwidth between electronics and us, right? Because
Mm,
now the bandwidth is rate limited by your typing speed, which is pretty
mm,
low.
yeah.
Like so input to your computer is limited by your typing speed, which is extremely low. You can think much faster than you can type. So and like again, typing is something that's already taken care of. So you can think of typing and then like having implants and then like you would you would see the words
Really?
being
So
typed.
if I'm a
Yeah.
writer, so I'm a writer, and I don't want to do any more typing. I just want to think my story out. I can actually do
Yeah,
that
if you had
today.
yes, if you had the like there was even systems that are lower tech than what exists today, where for example paraplegics had, and they can have control over a computer. Like Stephen Hawking, for example, had had control over a computer. It was even talking through the computer, right?
Right.
So and that was
That's
so
true.
that was done.
That's been going
That,
on for a long
that,
time.
yeah, yeah. So like, it's not even the most cutting edge thing right now. But
Well, I would pay right now for a helmet that I can put on my head and just think my stories out. Do you still
yeah,
need an implant for that level, or can you do it through the lower resolution of a helmet?
I'm not. I don't want to say something that's inaccurate, so I don't want to. But like I never I was fine with typing so far, so I was looking
Well,
for
some of us are
helmets.
really lazy, right? I mean, oh God, here I go.
Mm.
Did you write any papers with it? No, I'm kidding.
Yeah.
Well, that's very cool. So today we can do the both way thing. And then
Mhm.
I mean, where are you seeing improvements? Like I mean, like where is you said there's a lot in the paraplegic and in the depression spaces. When are we going to
Mhm.
get to the point where it's actually a little more accessible to just regular people? Because I think the same thing
Oh,
happened with
yeah.
when Neuralink first came out, and I read the all the articles, and I thought, well, this is really great, but it's really specific to a very small part of the population that
It
requires
has
this.
to be. It has to
Yeah,
be
yeah,
because there's nobody would you won't get it approved. Like
right,
think of I don't know, think of performance enhancing drugs, even cognitive performance enhancing drugs, right?
right,
They would have never been approved. Like nobody would the FDA would never have approved Adderall if it was for kids to do better in the school exams, right?
right.
But
Even though
when
they're
you
using it
have
for that.
yeah, exactly, right? But now it's something that's FDA approved, it's commercial, so
Yeah.
always things have to get approved for you can almost never have something approved for enhancement. It
Mm.
always has to be the entry to the market has to be for treatment of some condition or for getting somebody from subnormal levels to normal levels. And then somebody with normal levels can get the same, usually can get the same modality to get super normal levels. And
Yeah. I
that's,
mean, that's the
that's,
point. See, that's what I find interesting is that, I mean, we should be working towards supernormal levels, right? All of this technology and all of this should be should be designed to get us to like superhuman levels as opposed to the
I am,
just to the level just to regular human levels. When are we
I
going to get
am
there?
with you. I'm I'm with you. I'm with you 100%. But there's again, I'm 100% with you. But there's many people that are very resistant to this, right? Because
Mm.
it creates inequalities, and there's a lot of resist. Like if you were, oh yeah, I'm gonna give you something that can make you 10x smarter, and by the way, you have to pay me $100,000 for it. Then you would have you know a social revolution, right? But
Well,
if
we want everybody to
it
have it. Everybody can be 10x smarter, but then everybody's as smart as they are
yeah,
normally.
yeah,
So
yeah.
when everybody's smart, it's the same thing. So how do you fit crypto? Is it crypto or just blockchains? How do you
It
fit the
is.
blockchain into this puzzle?
So, yeah, very good question. So it's not. So it is. It is mimicking. So, large. Essentially, there's a property called biomimicry, right? Which is
Hmm.
mimicking the nature, right? So nature
Right.
has created solutions for many problems, and then by observing nature, we can uh, devise artificial systems that have that we in many cases we have never designed
Mm.
from scratch. And one of the like one of the main projects I'm interested is that I've actually started working for the past, I don't know, year, very actively on, is one where um, you can have an artificial system that is acts like a human organism. So
Mm.
you can create an organization layer. So our body consists of many organs, right? So we have, and also our like at many different levels, our for our body's function, we need coordination. So we need
Mm.
coordination from the organ level. We need coordination from our different parts, right? And even within a single cell, you need coordination of the different organelles for them to um, like for the mitochondria to do their function, and then for all the different organelles within a cell, right?
First, so
So
it's time to think like a futurist. It's the year 2035. Where do
mhm.
you see us in 10 years? Are we ever going to get to the point where I can just put a helmet on and I can have some robot do my job for me through these types of interfaces?
So in 10 years, yes, I think there's going to be a very good amount of uh, like a very large amount of what you do now manually will be done automatically. A lot of tasks will be commoditized. Even intelligence would be largely commoditized, and certainly, uh, what you asked, will have it will be much easier to use less invasive methods to, for example, read brain signals.
Hmm.
Right? So that,
Will it actually grow hair at the same time? Because I'm really interested in that. I don't know.
are you? I think that's a solved problem, Chris.
So that's not going to happen, right?
That's-
Maybe it can like
you're
re-stimulate my brain cells or something like that. Like, no, but
you're a
I'd love
short
to be
flight to
able.
Turkey for that.
I want to talk definitely the augmentation piece of it. I think is really important because we need to get to the point where we're evolving. I firmly believe that we've gotten to the point where nature has done as much as it can right now, and it's evolved us to the point where we can start evolving ourselves, right? So we need to be able to augment ourselves with electronics and other things to make ourselves, more, maybe not superhuman, but let's call ourselves more evolved humans. So
Mhm.
your space is definitely taking us in that direction, right?
Yes, it does, and that's like the main criticism of our space, right? Because I told you it's a highly
Criticism,
contested.
that's great.
Yes,
It should be the opposite
yes,
of criticism.
yeah. Like, I mean, it's the same with gene editing, right? I mean, our space and gene editing, they both have the potential to cure many diseases, and they have the potential to create almost super, like augmentation, right?
Yeah.
But like create superhumans in
Hmm.
some sense. Uh, and that's a pain. Like it's an open societal issue that people have exactly zero consensus on. Like if that's okay, I do think that's okay. Uh, like at least to some extent,
Mm.
but like there's huge like every time someone even just expressing this opinion is extremely controversial, right?
Oh yeah.
And yeah.
Well, the whole transhumanist movement is really interesting to me because on the one hand, people are really dissing it because nobody wants to go there, but on the other hand, I mean, don't we want to create better human beings? I mean, we should want to create better human beings, right?
Yes, and again, I'm 100% in line with you. But there's a host of questions like, is this openly available to everybody? For most new technologies, that's not the case,
Right.
right? Unless it's somehow forced to be available for everybody, then there's downstream effects from even if something is available to some group of people earlier on and something that augments intelligence, then you can very easily imagine that those people will concentrate wealth like no one else, right?
Oh yeah, for
Or
sure.
that they would. So inequality can perpetuate, or those types of things can perpetuate. And there's like then for gene editing, it can be even worse because
It's too bad.
uh,
Just think of
yeah,
where we
it's
could
the
be if we just allowed these technologies to 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 be used. I mean,
yeah.
maybe they are, but we just don't know. Maybe
So
maybe. maybe there's exceptional individuals out there who are really exceptional, but we don't know
So,
if they're using these technologies to be exceptional, right?
for example, for gene editing, there was a Chinese scientist that create. Have you heard of the CRISPR babies?
Yes,
Like in
yes,
China. So
yeah.
like he knocked out the gene that was, that was associated with HIV, with
Hmm.
contracting, like getting AIDS, right?
Yeah,
And like it also was related to intelligence, right? And
just that little
so
extra
those
bit.
babies, and so those babies are most likely alive now. But he went to jail, right? And
Mm.
it is kind of scary, like doing those types of things that can progress throughout generations is kind of like there can be downstream effects that we have not thought of. So that's why I think caution is warranted.
Yeah, but
But
the upside, man,
those
the
things,
upside.
the the upside is crazy, and those things will happen whether
Oh
like
yeah,
I think there's no stopping those types of technologies.
yeah.
So like I think the path is definitely uh, first getting um like treating disease, which I think is you know I think it's a perfectly good pathway. Like it's too bad we're alive now and not in 100 years maybe, but
But who knows? Maybe these technologies will help us to live 100 years. We
yeah,
just have to unleash them and let them go. Anyways,
yeah.
unfortunately I gotta wrap up, but thank you so much. This has been great. So if somebody wants to get in touch with you, what's the best way?
So through LinkedIn, I would say.
Hmm.
Like so Konstantinos Kallitsis, I think I can drop like give you or like email at kk740 at cam.ac.uk.
Okay.
Uh,
And I'll put all the links in the show notes so people can go directly to you. So this has been
excellent,
great. Thank you
Chris.
so much. We should probably talk again, except on the moral implications of all of this,
Let's
because I really want to
let's
get into
do
that.
let's
All right,
let's
sir.
do it. Let's do it.
Talk to you later. Have a good
Thank you
one.
very much, Chris.
Thank you.
Bye.
Bye.
Pixels and philosophies merge and mold, a future untold, unseen.